Hey guys, we're looking at area and volume of similar figures this time. And the first thing that I want to emphasize back when we were talking in the unit of measurement, really important that you remember your unit conversions. So in this case here, working out that there's how to convert from millimeters to centimeters or centimeters to say kilometers, what you're dividing by and what you're multiplying by. Okay, so you should have all of those, I guess, diagrams and unit conversions from last chapters in topics that we've covered before. And then if we were to convert units of area, you need to understand that it's not the same conversions as you would do with length because everything is squared. Okay, so rather than there's 10 millimeters in every centimeter, there is going to be 10 squared millimeters in every centimeter squared. Okay, and that's just a really good way to really think about how many decimal places you also need to move, not just one, but two. Not when you're going from centimeters squared to meters squared, it's not 100, but 100 squared. So you don't move the decimal point 2 times, but you need to move the decimal point 4 times. So this is just a recap from our unit of our topic chapter of measurement that we covered before, and I really encourage you to revise over that. Same thing with volume. This time, because volume is in units cubed, we are converting things relative to that. So instead of 1,000 meters in every kilometer, we have 1,000 cubed meters in every cubic kilometer. So you want to make sure that it's so we're converting one unit from of measurement to another. Instead of dividing by 1,000, we're dividing it by 1,000,000,000. Okay, so 9 decimal places instead of 3. And you can see that how that is a really big deal, a really big difference if you don't apply the right steps. Okay, so what I want to, I guess, exercise is this whole idea of scale factor as well. And let's say let's say we've got 2 squares, okay? Let's see if we can get this automated. Yeah. No. Keep trying. Oh, it's not working. Okay, that's all right. So we got 2 squares here. We'll say this one is, the length of this square is 2, and the length of this one is 6. Okay, so if we were to revert back to scale factor, we've got a scale factor of 3. Okay, so you've got the image. The image is on the right. Okay, and the original is on the left, which is 2. So 6 divided by 2 is 3. Okay, this is 3 times bigger, or the length is 3 times bigger than the length of this original square. Now, and I want to emphasize that this is just length. Okay, so then if we move on to area and compare it, so area is length times width. So the smaller one is 2 times 2. The area of the bigger one is going to be 6 times 6. Okay, and this case, instead of 4, so let's call it meters squared. Sorry, let's make the unit of measurement meters. So we got 4 meters squared versus 36 meters squared. All right, so you can see that the difference between the two is that the area, okay, so the area, the scale factor of the area is 9 times. So area scale factor is 9. So I want to probably go onto volume in this case, and hopefully you'll pick out a pattern here. So here's our volume. We've got a third dimension in this case, and so let's go volume for the smaller cube is 2 times 2 times 2, which is 8 meters cubed. Okay, and with the volume of the larger one, it's going to be 6 times 6 times 6, and that is 216. Okay, so 216 meters cubed. And the scale factor, so the volume scale factor, is actually 27 times. Okay, so the volume of this cube here is 27 times bigger than the volume of the smaller one. The area of the face of this square is 9 times bigger than the smaller square. And the scale factor of the length of this square is 3 times bigger than the scale factor of the smaller square. Now, I don't know if you picked up the pattern, but I'll probably go back to this here. So remember how scale, we've got units of length is just standard lengths, okay? So let's just focus on meters, okay? It's just a standard M. But then the moment that we convert things with area, it is squared, okay? And then when we move on to units of volume, then we're looking at cubed. All right, so we're starting off with 3, okay? So 3 is the first, just for length. Let's revert back to indices, okay? And have a look at 9 and think of indices and how we can actually simplify 9 into index form with a base of 3. This is actually 3 squared. Yep. Okay, so area is units of squared. It's actually squared of 3 makes 9. No coincidence there. And then we know that volume is in cubic, I guess, units cubed. So then, you know, what are the chances that 3 cubed is actually 27? So the good thing is when you look at the scale factor of length, of area, and volume, it all applies with the same rules. Okay, so area squared, volume is cubed, all relative to what the scale factor of the length is. All right, so hopefully that helps you guys with these questions. If you've got any questions, let me know, and I'll see you in the next one.